differentiate between them from the perspective of the intermolecular force. What's the intermolecular force? This is the force between this molecule and the next one. So as you can see, the molecule and the next one are so close to each other, which means that the intermolecular force, the force that holding them together, is very strong. Then going on to the liquid, the forces between the molecule and the next one is also strong. We can say not very strong, but they are strong. In the gas, the forces between the molecules are so weak. That's why they are not holding position beside each other or near to each other. So the intermolecular force is very weak. What about the intermolecular spacing? The intermolecular spacing means the space between the molecule and the next as well. So as you can see here, the spacing between the molecule in a solid is very small. They are closely packed, no space at all. But here in the liquid, they are loosely packed. Somehow you can see a distance. You can see that there is a distance between one molecule and another. While here in the gas, they are very large. The spacing is very, very large. The motion of the particle here, the particles can only vibrate about their position. They cannot go anywhere. While here, they can slide over each other, those liquid particles. While in the gas, they are rapidly and randomly in all directions. Regarding the volume and the shapes, the solid are taking a fixed volume and a fixed shape. As you can see, here the liquid are taking a fixed volume, but it can take the shape of the container. Okay, and then a gas, neither fixed shape, neither fixed volume. Okay, then the compressibility, incompressible. For the solid, they are not compressible, you cannot compress them. The liquid, slightly compressible. In the gas, they are compressible. Now moving on to the next part, which is the temperature. The temperature is the measure of an average kinetic energy of the molecules. So there is a relation between the kinetic energy and the temperature. Whenever the kinetic energy increases of the molecules, the kinetic energies of the molecules increases, so it means that the temperature will increase. Now we will move on to our relationship. We will have something called PVT. This is the pressure, volume, and temperature, the relation between them. First of all, we will start to have three experiments or three relations. First relation is the volume with the temperature, and we will see what happened keeping the pressure constant. Then we will have the pressure versus temperature keeping the volume constant. At the third, we will start to have a relation between the pressure and the volume. Okay, now let's talk about the volume versus the temperature when we have a constant pressure. First of all, if we have a piston like this, and inside this piston, we'll have molecules, gas molecules inside. And then you apply a heat down here, a heat source. What will happen? Let's take it logic. What will happen first? The temperature will increase. Then kinetic energy will increase. Yes, kinetic energy means there is a motion, so the speed will increase. The spacing between the molecule will increase as well. And then the volume will increase. All of this will happen vice versa. If the temperature decreases, everything will decrease. This is one thing, one description about the expansion. The expansion is the increase in the volume of a solid, liquid, or a gas. Whenever we have an expansion, it means that there is an increase in the volume due to the increase in the temperature. That's the expansion. Type. Expansion will happen in solid, liquid, and a gas. So now we will continue with expansion. We shall start saying that expansion in gases for sure will be much, much more than the liquid and will be much, much more than the solid. So the expansion in solid is the least expansion, while in the liquid will be much more. In the gas, there will be much, much, much higher expansion that will occur. Okay, we have the expansion in the bridges, railways, and telephone cables. Let's see how the expansion in the railways will occur. Here is the railway track. As you can see, whenever the railway will have a heat, they will expand. Whenever they have cold weather or cooling, they will contract. So what if we have this railway and it's no spacing between the railway? They are leaving no spaces between the railway during the sunny day or a hot day. What will happen? Oh, it will fall over. So what we should do is that we should keep a distance between the railway. We will not close them on each other like this. So the idea here is that you should keep a small distance for the expansion to occur. That's what's happening in the railway, so that it will not bend like this next time. Okay, this is the idea of